All right, so this is the worksheet on solving system of linear equations by substitution. So always make sure you're reading the directions. So you had to use substitution here. And these are the two problems. And so we have these two systems of linear equations, and you want to solve the systems by substitution. All right, so let's go ahead and look at number one. So here's number one. We have the system, and these are the two equations, and I want to find the solution, meaning I want to find what ordered pair will make this equation and this equation at the same time. Now remember, in terms of graphs, the solution will be where these two lines intersect. And for us, these two equations right here, these two systems, the pair of lines in each one will intersect at just one point. So that point of intersection would be the solution. But we're not going to do this by graphing. We're going to solve the system by substitution. One of the resources you had when you looked at the lessons was this resource here. So these were the steps to solving a system using substitution. Step number one, you want to isolate one of the variables. Well, number one, if you look at problem number one, the top equation, the variable y is already by itself. All right, so there's no work to do for step number one. Step number one's already been done for you. This is the equation you're going to choose. Now, as we go through the process, notice that you want to choose an equation. You want to choose an equation in which getting one of the variables is an easy process. You don't want any fractions, or you want to try to avoid fractions. It's not always possible, but whenever you can, when solving a system by substitution, you want to avoid fractions as much as possible. So if I were to pick the second equation right here, and I were to solve for x, I would have to divide both sides by -4. And by doing that, I would have a fraction here, because -6 divided by -4 is a rational number. It's not an integer. And in this case, I would get an integer, but I would have a fraction here. And so solving for x would not help. Solving for y would not help either, because I still have a fraction here. And -16 divided by -6 is also a rational number. I'm not going to get an integer. So if we look at the problem, it is the first equation that is more helpful. I can solve for y, because y is already by itself. And if I wanted to, just to let you know, I can also solve for x, and that would work as easily also. So whenever possible, when doing step number one, when you're asked to isolate one of the variables, look for a variable in your system in which the coefficient is already a 1 or a -1. And in that case, it is very easy to solve for the variable y or x. So going back to step number one, this one's already been done for you. Step number one's already been done for you, so y is already by itself. So step one, y equals x minus 4. And if I want to get x by itself, you would have said x equal y plus 4 instead. All right, it doesn't matter. I would have kept this one because y is already by itself. But regardless of which one of these you used, you would take whichever one and you would go to the second equation. So that's step number two. So step number two says substitute the expression from step number one into the other equation. And the resulting equation should have only one variable, but not both x and y. You would either have all x's or you would have all y's. And as you do this, you're going to see that that is the case. So if I take this one right here, so wherever I see a y, that's what I solve for, wherever I see a y, I'm going to substitute x minus 4 into the second equation. And if I had used this one right here, I would have substituted y plus 4 rather into the second equation for x. Okay? All right, now let's go ahead and do the substitution. All right, so when I do the substitution, so this is step number 2. So I'm going to get negative 4x minus 6 times y is this, x minus 4, equal negative 16. So you had to show this step. All right, so that's important. You had to show this step. Then you're going to solve this linear equation. So notice that the only variables you see in this case is x. If you had used this one, the only variables you would see would be y in that case. All right, but your final answer, your ordered pair, would still be the same. You just, in this case, solving for x first, and if you use this one, you're solving for y first. All right, so go ahead and use a distributive property. I get negative 4x minus 6x, a negative 6 times a negative 4 is a positive 24, equal negative 16. Combining like terms, a negative 4x and a negative 6x is a negative 10x plus 24 equal negative 16. Solving for x, I'm going to subtract 24 from both sides. So what you do to one side, you do to the other. And I get negative 10x, this is 0 when I combine like terms, is equal to a negative 40 right here. All right, so now dividing both sides by negative 10, I now get that x is equal to 4. A negative 40 divided by negative 10 is a positive 4. So far, my solution, and the directions did say, if I go back to the directions did say for the solution, write the solution as an ordered pair. All right, so we're going to do this as an ordered pair. So far I know that my x coordinate is 4. All right, and then I'm going to solve for y. Well, here's the thing. Right here, y is already by itself, right? So it's pretty easy to solve for y. So then we're in step, okay, so we did step 4. So step 4 was to substitute the result. Well, okay, step 3 was to solve the new equation. All right, so I did. So that's step 3 right here. All right, all this work is step 3. Step 4 is to substitute the result from step 3 into either the original equation. So here's my result right here. So x is 4. And I go back to the original. Always go back to the original, and you substitute, wherever you see an x, you substitute 4. It does not matter which one you use, by the way. You could do both of them. Just to check to make sure that both my y's are going to be the same, but it does not matter which one. I'm going to go ahead and use the top one since y is already by itself. So I'm going to do the step 4 right here. So y equals x minus 4, and so therefore y equals, remember x is 4, right? So you can say 4 minus 4, which is 0. So there's your y. So my solution is 4, 0, and you can check, all right? You don't have to check, but you can check mentally, and we'll do it mentally, and then I'll write it out. So remember, what I just found was the ordered pair was the x and y that would make both those equations true at the same time. And if I were to graph those two lines, they would intersect at that point. So let's check it. So x is 4, y is 0. So 0 equals 4 minus 4. So 0 equals 0, right? 4 minus 4 is 0. Over here, a negative 4 times x is 4. So that's a negative 16. Minus 6 times y is 0. So negative 6 times 0 is 0. So this becomes a negative 16, and a negative 16 does equal negative 16. So what you have when you check this, and if you do it by paper, so if you check it, you're saying x is 4, y is 0. So you have to check each of those equations. So here's my first equation, and here's my second equation. You have to verify that when you substitute x is 4 and y is 0 into both those equations, the left side equals the right side. The left side equals the right side. So y is 0, so you're seeing if 0 equals x is 4, so 4 minus 4, and that's true because 0 does equal 0. Over here, negative 4 times x is 4, minus 6 times y is 0, and you want to see if that's equal to a negative 16. Well, negative 4 times 4 is a negative 16, 6 times 0 is 0, so that's minus 0, and negative 16 minus 0 is a negative 16, which is what the other side is. All right, so that's how you check. All right, so that was number 1. So not that bad, right? Okay, now let's look at number 2. So number 2, my system is this. So I have x minus y equal negative 4, and then a negative 2x plus 3y equal 6. All right, so step number 1 says you want to choose one of those equations, and you want to get one of the variables by itself. Remember, it is ideal that if you have one of these equations in which the coefficient of x or y is 1 or -1, that's the one you should use. I would not choose a second equation because if I get x by itself, I would have to divide everything by I would have to divide both sides by -2, and then this would end up being a -3/2, which is not an integer. Now this would be an integer because 6 divided by -2 is a -3, but I would have a fraction. Same thing if I divide both sides, get y by itself here, divide both sides by 3, I would have a -2/3. 6 divided by 3 is 2, but I would have a fraction here. I would not have an integer. All right, so picking the second equation is not going to be helpful. You want to try and choose one. You want to try and choose, if possible, it's not always possible, but if possible, you want to try and choose an equation in which it is pretty easy to get x by itself or y by itself and not have any fractions. So notice see the coefficient of x here is a 1, coefficient of y is a -1, it is easier to deal with it by using the 1, by using a variable where the coefficient is 1. So here's the one that's 1. So step 1 says I'm going to take that first equation and I'm going to solve for x because x has a coefficient of 1. You could solve for y. It has a coefficient of -1, but you would have to divide both sides by -1 at some point to get y by itself. So I get x equals, and if I add y to both sides, I'm going to get y minus 4. So this right here becomes x equals y minus 4. All right, so that's your step 1. Step 2, remember, says I take what I just found and I substitute into the other equation. So my other equation now becomes this one. So in place of x, I'm going to substitute y minus 4. So here's my x right here. So I'm going to substitute y minus 4. So I get -2 times y minus 4 plus 3y equals 6. So that little statement right here says the resulting equation should only have one variable, and it does. The only variable you see is y and on both sides. And so now solving this linear equation, I'm going to go ahead and distribute, and I'm going to get -2y. A -2 times -4 is a +8, plus 3y equals 6. A -2y plus 3y is y. So I get y plus 8 equals 6. Subtract 8 from both sides, I get y equal a -2. So that's my y coordinate of my solution. So far my solution, I know, is going to have a y coordinate of a -2. So remember, the direction said write the solution as an ordered pair. To find the x coordinate, to find what x is, step 4 says I take what I just found and I substitute into either of the original equations, the original. So these are my originals, right? So I'm going to go ahead and use the first one. You can use the second one, does not matter. All right, I'm going to show you both, but it does not matter which one. I'm going to go ahead and use the first one. So I have x minus y equal -4. So what that step says is I go to this equation, and wherever we see the y, I substitute -2, and I solve for the other variable, and the other variable is going to be x. That's what I'm looking for. So I get x subtract a -2 equals a -4. X subtract -2 means the same thing as saying x plus 2 equal -4. Subtracting 2 from both sides, I get x equals a -6. So there's your solution. So my x coordinate's -6 and my y coordinate's -2. Just to show you, if you had, now remember, you're done here, all right? This is the work. But some of you could have used the other equation. So I just want to show you what you would have had to do if you had used the other equation. So if you had used, in this case, -2x plus 3y equals 6, let's see what you would have had to do. So remember, y is -2. So in place of y, I'm going to substitute -2. So I get -2x plus 3 times -2 equals 6. So I get -2x, and positive 3 times a -2 is a -6 equals 6. Adding 6 to both sides, combining my terms, I get -2x equals 12. Dividing both sides by -2, I get x to be, -2, I get x to be 12 divided by negative 2 is a negative 6, and that's the same thing I got here. All right? So it did not matter which equation you used. All right? So once you find the value of one of your variables, you go and you substitute that into either of those equations. Either the first one, get the other solution, or the other, and you get the same answer. Okay? All right. And you can check, and it wasn't necessary to check, but some students do check if they have time. On a test, sometimes you don't have time to check all your solutions, but if you do, then go ahead and check. It doesn't hurt. So to check, remember to check, and let me go ahead and do that here. So to check, remember it's not necessary. You didn't have to do that. But to check, you're going to go back to each of those original equations. So x minus y equal negative 4, and the other one is negative 2x plus 3y equals 6. And you're checking to see if negative 6, negative 2 is a solution, is the solution. We're saying it is, and then we're just going to check it. So this is your x, this is your y. So we have x, which we know is negative 6, subtract y, which we're saying is negative 2, and I want to see if that's going to equal the other side, which is negative 4. Well, remember, subtraction, you can always change to an addition problem by adding the opposite. Adding the opposite. So this becomes negative 6 plus a positive 2. So x subtract negative 2 means negative 6 plus 2. And negative 6 plus 2 is a negative 4, which is what the other side is. So 4, that's correct. You got to check the other one. So negative 2 times x is negative 6, plus 3 times y is negative 2. And I want to see if that's going to equal positive 6. Well, negative 6 times negative 6 is a positive 12, plus 3 times a negative 2 is a negative 6, and 12 plus a negative 6 is a positive 6, which is what the other side is. So what we have is correct. Now, if I were to graph those two lines, just remember, if you were to graph this, which was not the direction says solve this by substitution, which is what we did. But if you were to graph this, those two lines would intersect at this point, at only one point, because there's only one solution. All right, so that's it. So that is the key to the solutions to solving these two systems by substitution.